Hey everybody, this is Larry. This is day 20th of the Leetcode July Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I'm not going to do a bonus poem today just because I think the contest is actually in like, oh, 9 hours? Yeah, maybe I can do math. So yeah, so definitely, so stay tuned for that, or if you're doing it, good luck. And also wish me good luck. But anyway, let's get to today's poem. Fridays I'm always just like so beat, especially these days. But let's take a look. We have 1605. Find valid matrix given row and column sums. You're given two arrays, row sum and column sum of non-negative integers, where row sum sub I is the sum of the elements, and column sub sum is the sum of the jth element. Okay. You do not know the elements of the matrix, but you do know the sum of each row and column. Find any matrix that satisfies the requirement. Okay. This is only a medium, huh? These things are always like kind of like feels like they're a little bit tricky to figure out, but I think we can do it okay. So let's say the row is 3. This is 8. I want to just also look at constraint. So this is 10 to the 8, so you can't just like, my initial idea was just to kind of put one number at a time and as long as it fits kind of thing, but that would take too long because it's 10 to the 8, right? So so this is constrained to 500 by 500. Okay. I think there are also multiple answers, right? So I think as long as we have a strategy that kind of works, then I think we should be okay. So for example, this is 3, 8, and maybe in ASCII art is a little bit clearer. So you have 3 and 8, and you have 4 and 7, right? And here, maybe we can just greedily, right? Like, this is a 4, this is a 3. We can just put 3 here. It doesn't really matter. And then now we have 0 left, 1 left, right? And then here, we have 0, so it has to be 0, dot, 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 right? And yeah. And here it's 1, so it'll be 1. So this is a 7, and this is 7. I think that should be good, right? Like, I don't think there's any. And the reason why this kind of works is just that any solution is fine, and I think there's just so many possible solutions. So so I think now that we have this idea, we can definitely just do it, right? So then now we have maybe answer is equal to 0, or maybe just go with none, say, times C for right? So then now you have an R by C matrix. We return it at the end, and then now we're gonna just do it one by one. In range of R for J in range of C, and then now answer sub ij is just equal to min of row sum sub I cos sum of j, right? And then I mean, you can maybe just to do it a little bit easier to type, maybe v is equal to this, and then now I mean, I know this is sum, and that should be good, right? I mean, at least that's the idea that we're having. And the reason why this is good is because every movement that we make, there's no contradiction, right? Like we're never gonna have a wrong answer from this, just because that's the way it is, and so every time you play something, it is gonna be, incrementally better than the answer that you have, and as long as you use all of them, and here also, right, when you get the min of row or one column, the thing is that every time you do this, you get rid of one of the row, you get rid of either the row or the column, right? Because that's not strictly true, because this could be 0. So, but in a way, at the very least, maybe another way to say it is that in this I loop, we are gonna get rid of a row at a time. I don't know, but my point is just that you're always gonna make, it always improves the solution, and it doesn't give you, like, nothing gives you the wrong answer unless there's no, I mean, I want to say there are no decisions, but there are other matrices. But the way that this is, this is a constructive problem or constructive algorithm. And yeah, and every iteration, I guess, unless one of these is zero, we do zero out at least one of these. So I think that's, that makes it okay. Maybe that's not a great proof though. What is the yeah? I mean, okay, that's what we did. Do they have a proof other than is it time and space optimized? Wait, what does that mean? I mean, this is this is not really true. I mean, that's quite an assumption. You should just state it clearly. Because for a second I was like, oh, how do you get? I mean, that's the size of the output. It's like, no, I mean, you could. People sometimes usually say it's all one extra space, but no one. I mean, I don't know. It's just a very sloppy way of putting it, if you ask me. What is this other thing? Why is this better? Time and space optimized. Oh, it's just that. Okay, I see what they're trying to do. So yeah, that's what I was gonna say. Like conceptually, they would try to do it in like O plus R plus C, but you still have to you create the size of the output, which is going to be R times C. So you can't really do better than that. And again, the space optimus complex is a little bit awkward. Yeah. I don't know if you call it greedy though. I mean, I think it is more of a constructive thing. I mean, you could say that this is greedy and that every decision you don't take. The thing is that you're not trying to find like a sub problem in which the like there's nothing to optimize, so it's hard to call it greedy. It's just like a constructive thing. It's a little bit awkward in general. I was hoping to I was hoping to I was hoping to yeah, I don't know. I was hoping to kind of just learn a little bit about the proof, but I feel like this. I mean, they kind of proof. I don't know. It wasn't really proof. I don't know. That's all I have for today, though. I don't know. It is what it is. Hopefully, this is satisfactory. Have a great weekend, everybody. Stay good. Stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.